Hello friends, in today's video we will see how to solve the questions of the UPSC Civil Services Optional Physics Paper 2. So let's start with our question number 1. So what is question number 1? So here in this question we have to prove that Bohr's hydrogen atom approaches classical conditions when n becomes large. When n is very greater than 1. Take an atom and an atom is transiting from n1 is equal to n to n2 is equal to n minus 1. So this is a transition and here n is very large. So we can find the energy level for n1 and energy level for n2, and so we can find out the frequency of emitted photon during the transition. So we know that energy in Bohr's hydrogen atom model has a inverse square dependence CHR n square. Energy is inversely proportional to n square. Here R is Rydberg constant. So we have to basically remember this. So our E1 is where n1 is n and n2 is n minus 1. So we simply write CHR by n square and here CHR over n minus 1 ka whole square. So our frequency we can equate by difference between the energy levels. So mu comes out to be E2 minus E1 over Planck's constant. So CHR we can take out this constant over H, this 1 minus n square minus n minus ka whole square. So we can further solve it. So our expression for frequency comes out to be CR over n minus 1 whole square minus n square n minus 1 ka whole square. So we have to solve this. N square plus 1 minus 2n minus n square. So we have to do this simple mathematics. Simplifying this, 2n minus 1 over n square n minus 1 square. So if our n is very great, larger than 1, greater than 1, so we can write n minus 1 as n. So and similarly 2n minus 1 term as 2n. So it becomes it is approximately comes out to be CR 2n over n ki power 4. So it comes out to be CR twice CR over n cube. So our frequency dependence is 1 over n cube as it approaches the classical conditions या case. So here, according to classical EM theory, a rotating charge, because a rotating charge with a frequency mu, a rotating charge with a frequency mu will emit a radiation of frequency mu. Similarly, on the other hand, if we use the Bohr's postulate, first postulate is the orbital frequency, the allowed orbits are circular. Second, and the angular momentum is quantized. So angular momentum is quantized, so we can write this MVR. It can take discrete values, so it is a multiple of h cross, so we can make use of this relation. And another, because it is orbiting in the circular motion, so we can write this as 2 pi r, circumference of the orbit, circular orbit having radius r, orbiting velocity, and its time period. So our frequency comes out to be V over 2 pi r. This is velocity of orbiting charge and this is frequency. So we have to find out the frequency in terms of n. So we have to substitute V nh cross over mr in this relation over 1 2 pi r. So we can simplify this as, so we have to find out r in terms of n. So we have to simply equate the centripetal force by Coulomb force. Here Z is equal to 1 for hydrogen. Since the charge is orbiting in circular orbit, so we have to balance the centripetal force with Coulomb force. So we can have mv square k ze square by r. Here z is equal to 1, so mv square is equal to ke square by r. So we have to find out r in terms of n. So we have to substitute using this relation, v is equal to nh cross over mr in this relation. So m nh cross whole square by m square r square ke square by r. So cancel the m and 1 r, so n square h cross square over r mr ke square. So r can be written as n square h cross square m ke square. So our frequency we can see here is nh cross 2m r square, nh cross 2m 2 pi m r square. So we have to substitute r here, so we can find out 2 pi m, it's n square with n cross 4 m square k square e to power 4. So it's some constant c 1, and then we have to separate out the n terms, so it comes out to be inverse dependence of, ठीक है, it is inversely dependent on n q. So it is identical to the frequency of the emitted photon. This is it for today. If you have any doubts related to this topic, if you want any proof or derivation related to any of the formulas used in this video, you can write me in the comment box. And thank you for watching this video.